On the sensor end, we use the three basic sensors of the Quest: the infrared rangefinder, the ultrasonic rangefinder, and the thermistor. All the sensors are calibrated depending on their respective datasheets and some testing-based calibration. To retrieve the data, we use the ADC1 channel 03 and 6. We decided to not use the second SC since it would not have been available if we wanted to use the Wi-Fi. For the thermistor, which was especially sensitive to noises, we decided to implement a low-pass filter to make its output more steady and in the range of the ADC. Finally, all conversion functions from raw data to voltage to distance or temperature are homemade. We settled on making our own function for a better accuracy and understanding of the process.
To communicate between the sensors and the web application, we established a web server on the ESP itself. This server takes the data and converts it into a delimited string. This string is then passed onto the web server, where it may be fetched by any device on the same network via a GET request. This data is accessible via any browser using the proper URI appended to the web server's IP address. This means that our system of sensors requires no computer to process or share its data. It can be set up wherever you'd like, requiring nothing but a battery and a network connection. Our web server also contains code for processing POST requests, in which the user could provide input from any device on the same network. This capability could allow for the easy addition of features, such as requesting the data from a particular timestamp. The greatest challenge in setting up the web server was learning all the formatting required for the various types of HTTP requests and understanding how our web server can best handle them.
For the web application, we have a client side and a server side. The server side serves up an express HTTP server to host the web application. Then, we get the data from the ESP32 web server using a GET request, which is stored into a JSON file on the server side of the Node.js. The data is then sent from the backend to the front end using a WebSocket. The data points are plotted in real time on the web page. We encountered two problems. The first problem was we mixed synchronous and asynchronous functions, causing incorrect memory access. The second problem was deciding whether certain operations were more optimal to do on server side or client side.